This conference will now be recorded.
Good evening, everyone. Is my voice audible? Please respond. Guys, is my voice audible or not? Okay, thank you. Okay, yesterday we designed some basic circuits, right? Okay, now I will directly design the stable multivibrator circuit. After that, we will go for another circuit. Okay, today is the last day for PCB wizard. Okay, if topics were not covered, we will discuss it on Monday also. But as per schedule, from Monday you will be working with advanced software. Okay, nothing but from Monday onwards we will be working on Easy EDA, which is an online tool. Okay, now I think everybody have the circuits with you. I will directly design the first design the circuit so that you can understand easily. Okay, I have given some task yesterday, but only few members completed the task. There are some errors in your designs. Okay, I will explain what are those errors. Okay, this is the circuit, right, for a stable multivibrator. Okay, now we will design the PCB for this. Okay, now open the PCB wizard software. Okay, I think everybody have the circuits with you. Okay, just try to design PCB wizard. Did anyone try to design the stable multivibrator or any other? Okay, just take the components. For power supply, always take a terminal block. Okay, let me zoom in for you. Okay, try to reduce the size of your circuit as much as possible. the size should be less. From 3 inches resistors of 3. Not updating. Okay, just a moment, guys. Guys, is it updating or not? Okay, just give me a. Okay, is it visible now? Okay, just take the components what are necessary to do multivibrator. Okay, even if my screen is not also, just take the components because you have the circuit. Okay, even if my screen is not working, also take all the components. Okay, which are used for a stable multivibrator and to root your circuit. Okay, I will just try to reconnect. Okay, wait for 5 minutes, guys. I will just rejoin the meeting. Okay, I think I have a technical error. Okay, just wait. Meanwhile, take all the components which are necessary for a stable multivibrator and try to route your circuit. Okay. Okay, guys, is it visible now? Please respond quickly. Okay, thank you. Okay, this is the circuit, right, for a stable multivibrator. Okay, now take all the component footprints which are necessary. Okay, these are the footprints, right? Okay, you need a power battery terminal for power supply. You need a 8-pin IC for 555 timer, and you need 3 resistors and 1 capacitor and a LED. Okay, these are the footprints which are required in a stable multivibrator. Okay, now you can place the components as you like. Okay, there is no need to follow my design. You can place the components because circuit diagram is different from PCB layout. Okay, because the circuit and PCB layout will be different. Okay, just observe. Suppose if you open the circuit, the 7th, 6th and 2nd pin are in left side of your circuit, but when it comes to the IC, the 6th and 7th pin will be at the right side of your IC. Okay, I think you got the difference. The 7th and 6th pins are in left side for the circuit diagram, but when it comes to the footprint, the pin identification is from left side, right? Nothing but pin number 1, pin number 2, pin number 3, pin number 4, pin 5, pin 6, pin 7, and pin 8. Okay, like that, the circuit and the footprint are different. Okay, so that give the routing correctly without making any errors. Okay, just place the components as you like. As yesterday I have told you, if you are okay with the component footprints, you can delete the component names, okay, or values. Okay, I'm just deleting the component names and values. Okay, because I can identify the components easily. Okay, now place the components in such a way that no component should be overlapped with other component. Okay. I have placed my components like this. After this, I will start routing the circuit. Okay. Try your own ideas. Okay, as I have already told you, you can use the bottom space which is present to the bottom side of component. Okay. And never use a 90-degree angle in your circuits. Okay. Okay, now observe a small detail that many of you are doing error. Okay, you can take the track. Okay, just a minute. Some of you are taking the track to the next pad. Okay, nothing but you are overlapping the tracks with other pads. Okay, I will just explain it with an example. While giving tracks, okay, suppose if I start a track at the second pin of my IC and take the track like this to the sixth pin. Okay, this is the sixth pin, right? Now if you observe, I have given a track from second pin to sixth pin, but you can clearly observe that the second and third pins, after etching process, they will get shorted. Okay, so always try to avoid those type of routing. Okay, you should never take your track beside to the next pad. Okay, there should be a minimum spacing between your tracks. Okay, one more example I will tell you. You can take a track like this, but you can take a track like this. Okay, it has some minimum space, right? The capacitor pad and the track has some minimum spacing, but some of the people are taking track like, okay, just wait. If you take the track like this. Okay, if you take the track like this, after etching process, it may get shorted with the pad. Okay, this is not the correct process. Just make corrections in your circuits. You should never take the track beside of other components. Okay, okay, this type of connections, okay, should not be made because this track and pad can be shorted after etching process. Okay, I am deleting those lines. Okay, sorry guys, just okay, you should never take the track like this. Okay, always try to maintain some minimum spacing between your tracks. Okay, I think someone asked a question, how to reuse the size of track line. Okay, Mr. Manoj Kumar, wait, I will explain it. Suppose if you take a track like this, okay, okay, I will reduce it. Suppose if you took a track like this, okay, and you want to resize it or make some changes, just select the track, and after selecting, you can observe a small dot, right? If you take it to the corner of the track, you can observe a small dot, okay, then you can reduce the size like that. Okay, after selecting the track, if you go to the terminal endpoint of the track, you can identify a small cursor like symbol. Okay, if you drag that line, your track will change its shapes, or you can change the length of your track. Okay, like that you can adjust your tracks. Okay, and you can change the locations also. Okay, now you need to connect from second pin to sixth pin, right? For that, I will route like this. Okay, if you observe now, okay, there is no overlapping, right? It is not near to the other pads. Okay, and there is some proper spacing between the pads. Okay, now I can use like this. Okay, and from this sixth terminal, it should be connected to the capacitor terminal, right? Okay, like that you can route your circuit. Okay, now what are the pins remaining? Only the third and fourth, right? The third pin is output. You can directly connect it like this. Okay, never use a 90-degree angle. For that reason only I am taking the shape of a triangle here. Okay, after that, the ground pin should be connected to the LED as well as capacitor, right? Okay, now what is the pin that is left? Only the fourth pin of IC is left. Okay, the fourth pin and eighth pin should be shorted. Can anyone give me an idea how to connect those two lines? Only 4 to 8 pin should be connected. Can anyone give me an idea? Okay, you can take a track from the in between. Sorry, the bottom space of capacitor can be used for taking your track. Okay, just use your skills. Okay, like this. You need to track. Just take a track through the capacitor. You have bottom space of capacitor, right? You can use it for making the fourth pin connection. Okay. Now observe the circuit, guys. Can anyone find any mistakes in this? Okay. Observe the circuit. Only the fifth pin of IC is left over. Okay. The remaining all pins are connected. Okay. Now observe the PCB layout. Okay. If you identify the pins, you can clearly understand. The first pin should be connected to ground. Okay. We have connected it to the ground pin. After that, the second pin should be shorted to sixth pin. I have shorted it by using the bottom space of my IC. After that, the sixth pin is connected to the capacitor pin, capacitor and resistor junction. Okay. After that, the third pin is used for taking the output through a resistor. I have directly connected it to a resistor, and the resistor other terminal is connected to LED anode. The LED cathode is directly connected to the ground. Okay. Now coming to the left side, fifth pin is empty. The sixth pin is connected to the capacitor, and seventh pin should be connected at the junction of R1 and R2. Okay. And from eighth pin to fourth pin, you need a connection. For that, use the bottom space of capacitor. Okay. Just don't take the track very close to other pads. Okay. That is your instruction. Okay. For reducing the errors. Okay. Now my routing is completed. The next step is to take the board area. Okay. I have taken board area like this, and if you want to add any labels, you can take more board area, and after that giving the copper area. Okay. Now click on the, you can give the copper area, board area same. Okay. After that, copper label. Okay. Like that, you can place your label at locations where there is no footprint or components present. Okay. Now if you check the real world diagram, it will look like this. Okay. This is your IC footprint, and these are three resistors, and this is the LED, and this is a capacitor. Okay. Like that, you can design your circuit. Okay. This is the terminal block, and if you observe the artwork, okay, this is how your artwork looks like. Okay. This is the IC, and this is a terminal block. Like that, while taking the artwork as your printout, you need to take the normal diagram also. Okay. Because you may confuse with the artwork connections. Okay. We may change the component places, because for simple circuits we can identify the components easily, but when it comes to the large circuits, we need the circuit diagram also. Okay. Sorry, circuit layout also. Okay. Is it clear for everyone? If it is completed, I will give you 5 minutes. Okay, sorry, I will give you 3 minutes. Try to connect the bistable multivibrator circuit. Okay, bistable is nothing but you need to add another resistor and another LED in this circuit. Okay, by making simple changes in the circuit, you can easily convert it to a bistable multivibrator. Okay, just complete it quickly. We have more topics to cover. Just I will give you 3 minutes. Okay. Okay, guys, I will just try to convert it into bistable circuit. Okay, try to reduce the size because I can design the circuit in a 1-inch square box. Okay, for your understanding, I have created it in more space. Okay, just try to design the stable multivibrator in 1-inch square box. Okay, try to design the circuit in one box. Okay, don't take or don't use more space. Just try to improve your skills. Okay, now I will try to design the bistable circuit. Okay, for bistable multivibrator, you need another resistor, another LED light. Okay, for bistable multivibrator, just you need to add another resistor and okay, this is the circuit, right? You need to add another resistor and LED to your stable multivibrator, okay, which converts it into a bistable multivibrator. Okay, just try to design that circuit here. Okay guys, now observe my circuit. Can you find any mistakes in this? This is the circuit of a bistable multivibrator. Okay, I will just try to explain the circuit. Okay, remove the copper area, and now if you observe the circuit, you need to cross two resistors across power supply, and you need to connect the third pin, output pin, at the cathode of one LED and anode of another LED, right? This is the junction which is formed between anode and cathode. Now observe PCB layout. Okay, output is the cathode of one LED. Okay, and the anode is connected to a resistor. Okay, now the resistor should be connected, which is nothing but fourth pin or eighth pin of your IC. Okay, here the eighth and fourth pin are shorted together. Okay, you can directly connect it from here to here, and the cathode pin should be connected to the anode pin of another LED, and the cathode should be grounded through a resistor. Okay, like this you can complete your circuit. Okay, you can try your own designs. Okay, no need to follow my design. You can try your designs. Okay, there is no objection. Okay, you can design your own PCBs like this. You can change the okay, you can rotate the components, and you can change the places of components also. Okay, like that, try to design your own PCBs. Okay, the real world diagram will be like this. Okay, I will just change the color of the LED. Okay, now if you observe, this is the diagram of bistable multivibrator. Okay, this is the IC. From the notch, you will identify the first pin, second pin, third pin, and fourth pin, and in the opposite direction 5, 6, 7, 8. Okay, here are the two LEDs, and you need 4 resistors for bistable multivibrator, and you need a capacitor at the 2 to 6 pin junction. Okay, and terminal block is used for giving the power supply. And I think I have a question. Okay, Mr. Srinivas, what do you need about the pins? Pins do you need? What is your doubt? I did not get you. This is about the pins. Okay, suppose if you want the IC pins, okay, from the notch left side, it begins your first pin. Okay, suppose when you take an IC, just a moment. Okay, when you take an IC footprint, here you observe a notch at the top side, right? Okay, ఈ notch ki left నుంచి మీ అనేది start అవుతుంది. Okay, left side నుంచి ఐసి. మీరు గుర్తుంచుకోవాల్సిన విషయం ఏంటంటే, మీరు ఐసి తీసుకున్నప్పుడు ఒక నాచ్ అనేది ఉంటుంది ప్రతి ఐసికి. ఆ నాచ్ ఓకే, అండ్ రైట్ సైడ్ వచ్చి లెఫ్ట్ సైడ్ ఫస్ట్ పిన్ బిగిన్ అవుతుంది, వచ్చేసి లాస్ట్ పిన్ ఉంటుంది. ఓకే, ఇస్ ఇట్ క్లియర్ ఫర్ ఎవ్రీవన్? Okay, can we move to the next circuit? Guys, please respond quickly. Guys, is my voice audible? Okay, what is the next circuit? Can you tell me the name of our next circuit? What is the next circuit that we have learned in Livewire? Okay, thank you, Miss Susmita. Okay, guys, I will give you the task for you. Okay, complete pictures in WhatsApp group and post. Okay, I will leave that circuit for you. Okay, and show you the components. Okay, but for motor there will not be any footprint available for you. For motor, take the footprint of a buzzer. Okay, for motor take the footprint of buzzer. Okay, in the output there will not be available for motor, so just use the buzzer footprint for your motor. Okay, just complete the motor rotation control is your task. The PDT switch there will not, and for SP sorry DP not be any footprint available for you. There will not be any. Okay, just check the input DPDT switch available for you components. Okay, for that, what is the B voice not audible? Okay, sorry guys, I have an issue with my internet. Okay, is it audible now? Okay, thank you, Mr. Smita. Okay, guys, I have given a task for you, and you will not find the footprints for motor, okay, and for DP/DT switch. Okay, for DP/DT switch, you can use the connectors. Okay, use 2-pin connector and 4-pin connector. Okay, just use those connectors for switch, and for motor you need to use the buzzer footprint. Okay, now what is the next circuit that we have learned? Can you give me the name of next circuit? Okay, panic alarm, it is also a simple circuit. Okay, just try, I will try to design the panic alarm circuit. Okay, okay guys, sorry, I will design the LED flasher circuit. Okay, because it is bigger than the panic alarm. Okay, I'll try to finish it now. Okay, on Monday I will explain auto routing concept in PCB wizard. After that, Monday we will start with an advanced software. Okay, that is easy EDA. Okay, take the components which are used in LED flasher. Okay, you need 2 ICs for the circuit. Okay, you need 555 timer along with a 14-pin IC. Okay, you need to take a 14-pin IC because there will not be any footprint available for 12-pin ICs. Okay, okay, I think 14 pins only. Okay, don't worry about the pins. Just take all the components which are used in LED flasher circuit. Okay. I think you have the circuit with you. Take the components which are used in LED flasher. You need 10 LEDs and a 14-pin IC. Okay. Take the footprint of a 14-pin IC from integrated circuit. You need to take a 14-pin IC. Okay. In LED connections, we need to connect the pins from 1 to 10, right? Okay, in circuit diagram you will have pins from 0 to 9, but when it comes to the footprints of ICs, there will not be any 0 pin. The pins of IC starts from 1. Okay, always remember that there is no 0 pin in your ICs. Okay, you need to start from pin number 1. Okay, you need to take 10 LEDs. Okay, try to make the LED anode pin to the IC side because I have rotated the IC to right side. Okay, the first pin starts here. Okay, notch left side begins the first pin. Okay, like that you need to count the pins of your ICs. Okay, from 1 to how many pins does it have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, you need to connect 10 LEDs like this. After that, you need to connect the remaining pins. Okay. Okay, like that, take 10 LEDs. Okay, connect the LEDs to your IC. Okay, I think the stable circuit remains same because you already know how to connect the pins. Okay, there will not be any changes to your stable multivibrator circuit. Half of the section will be similar. Okay, just never maintain a 90-degree angle in your circuit. We will have a problem because the capacitor footprint is not sufficient. Okay, we need to take another footprint because we need two lines at the bottom of our capacitor. Okay, you will understand at the final why did I took that. Okay, capacitor. Okay, now come to the LED connections. Never give a 90-degree angle, as I have already told you. Okay, now if you observe, only I have connected 7 LEDs. Okay, the remaining 3 LEDs should be connected at the bottom side. Okay, just try to avoid any overlappings. Okay, just make sure that all the connections are well established. Okay. Okay, that will be a wrong connection if I make it. Sorry, I have made a wrong here. Nobody noticed. Okay, the LED should be connected from 0 to 10 pins, right? Okay, I have connected it to the wrong pin, but nobody noticed. Okay, because the 8th LED should be connected here. Okay, after that, you need to connect the remaining LEDs, 9 and 10. Okay, like that, all the 10 LEDs should be connected. Okay, now if you observe, we have remaining 4 pins, right? Okay, if you open your circuit diagram, you can observe the next pin. Okay, nothing but the 11th pin should be okay, left over, because in your connections one pin is not connected. Here also you should never connect the 11th pin. Okay, directly connect the 12th pin and you can short it to the next pin, right? 12th and 13th pin can be shorted. Okay, and the last pin should be given a output of a stable multivibrator, right? Okay, now take the connection like this. From the third pin output, just directly take a line. And you can connect it 14 pins because it is the clock input to your IC. Okay, now you need to connect the 13th, 12th pins to the ground, right? 12th and 13th pin should be connected to your ground. Okay, for that you need to take a track. Okay, now observe the circuit. Is it completed or not? Okay, I have connected each and every pin in the circuit. Okay, because I have used more space. Okay, try to in this reducing the size, and you can place the LEDs or whatever may be the components. You can reduce the size by changing the place of your components. Okay, this is the circuit of LED flasher, right? And auto routing concept. Okay, then auto routing concept is not preferred. You can clearly understand, but okay, I will explain the reason also. Okay, just like this, you should always try using the circuit like okay, and your interconnection. So X are not in 90-degree angles. Okay, you can observe here there is no track that is 90 degree. Okay. You can place whatever the labels you want if you have the place. Okay, but don't design large circuits. It is not recommended to reduce the size, and it is not not recommended. Okay, try to reduce the size as much as. Okay, now if you check the real world diagram, it will it will look like this. This is how you manual route your circuit. Okay, okay, there is no problem, Mr. Pawan Kalyan. That is not a big deal because you have already connected and designed the circuits. Okay, try to make sure that every pin is connected at your PCB design. Okay, design. And if you observe the artwork of this layout, if you observe circuit, it will look like this. Okay, artwork, you can clearly understand that only the black area. Okay, the black area is nothing but copper area. Okay, if you observe the normal diagram, okay, here you can observe the red color, right? All this red color indicates the copper. Okay, that will be those blue color pads and red color your X and copper area. This entire red color will be considered as you. Okay, once you keep this board in white area, which you keep etching. Okay, is the process clear for everyone? Try to reduce the size of your PCBs. Okay, I need all of you to do the homework. I have given a circuit. Okay, motor, speed and rotation control, right? Do that circuit by reducing the size, and I need all of you to design the stable multivibrator circuit PCB layout within 1 inch square box. Okay, try to design it and post the pictures in WhatsApp group. Okay, I have told about errors also. Don't take the tracks beside to the pads of other components or within the pads of same component. Okay, just try to maintain minimum spacing between the track, okay, and pads. Okay, that's it for today. From Monday onwards, we will be working with the advanced software, and on Monday, I will explain auto routing concept also, and I will explain what is the reason that we should not use the auto routing in designing PCBs. Okay, is it clear for everyone? Now, if you have no doubts.